Good day, people. It's Elton again. Today we'll be doing inverse graphs, the second part of the functions. As I promised that after the types of functions, part one, we will upload the second part, which is inverses or inverse graphs. So before you can continue watching this video, make sure that you watch the first part. Okay guys, here we come again doing inverses or inverse graphs, the second part of the functions. Before you can come to this video or this lesson, make sure that you go back and watch the first video so that you can understand the overview of what we'll be doing today. I greet you, this is Altin. Before I can continue the video or with the lesson, I'd like to thank those who subscribe to the channel. If you haven't subscribed yet, please make sure that you do the right thing. Okay, inverses. I won't explain much, but I'll just make you to understand it more easier. So, for an example, suppose you are given, or before I can just write what I want to write. Okay, for me to write an inverse of something, or for me to have something known as an inverse, I have to have the original point or the original graph, which out of it I will make an inverse. I don't know if you understand that. For example, I am given x is to y. Then they ask me to write the inverse of that point. Remember, the first thing for you to do in order for you to write an inverse of a point or of a graph, the first thing, make sure that you are writing. The first thing you have to do what? You have to swap every x and y coordinate with each other. Meaning that where there's y, you put x, where there's x, you put y. So since I have this point here, the inverse of this point, it will be y is to x. So that's the coordinates, or that's the inverse. You see this? Now, the second example, it can be 0 is to 6. They want me to write its inverse. Its inverse will be 6 is to 0. I hope you guys are following. Okay. The most important thing here is that they can give you something as f of x. Oh, let me just talk first about the notation of the inverse. You know that a graph is represented by f of x. We know that f of x, it is also y, even if it can be y of x. But this one here is different to this one, but there's a similarity there. Now, what is this? This is the original graph. Since I just said earlier that for you to write an inverse of whatever, it's either a point or a graph, you must have the original point or the original graph, which out of it you will have what? Something known as an inverse. Now, this is the original functional I can say maybe functional notation. Then this, it is the function, the inverse of this functional notation. I don't know if you understand that. And there are rules that are applying, or this notation, as I am saying that it is, or it symbolizes an inverse of an original f of x, meaning that you only use this notation only in a one-to-one function. I don't know if you understand that. You do not use it to a many-to-one function, but only in a one-to-one function. So if you're not understanding, or you don't know how to differentiate between these two many-to-one functions and one-to-one functions, make sure that you go back and watch the first part of functions. Alright, now you only use this notation in a one-to-one function, not a many-to-one function. Why? Because a many-to-one function, it's inverse. It is not a function, it is a relation. I don't know if you understand that. So for me to make it more easier, a one-to-one function or one-to-one functions, it is a linear graph and an exponential graph. So those ones, they are inverses, they become functions. But the inverse of a many-to-one function, it becomes a relation. So you only use this one in an exponential graph, or to write an exponential the inverse of an exponential graph or the inverse of a linear graph, not the inverse of a parabola, because its inverse becomes a relation. Now, they can give you an equation like f of x or a graph 2x plus 1. We can see that this is a what? It's a linear function. Therefore, it's a one-to-one function, and it is also a function. So it's a function, and what type of a function? A one-to-one function. Therefore, you can use that notation that symbolizes the inverse. I can write f of x as y equals 2x plus 1, right? Then for me to write the inverse, I have to swap every x and y coordinate with each other, meaning that where there's y, I put x, and where there's x, I put y. It's not like you are done now. You have to make y the subject of the formula. Therefore, x minus 1 equals 2y. Divide everything by 2, then you will have x over 2 minus half equals y. So this is the inverse. If you don't want to write it like this, since you know that it's a one-to-one function, you can write it in this format. Then you write this here. So it will be 1 and the same thing, because we only use this formation or this notation, functional notation, for the inverses of a linear and an exponential. So the most important thing before you can do whatever, you swap every x and y coordinate with each other, then you make y the subject of the formula. And after that, that's the inverse. The second one, y equals x over 2 minus 1. This is also a linear function. Y equals 1 over 2x minus 1. I can even still write it like this. Therefore, x equals 1 over 2y minus 1. Then x plus 1 equals half y. Then I divide everything by half, everything by half, everything by half. Then I will have y equals 2. You write the answers, or you simplify this. Then after your simplification, that will be the answer. But even if you can say, then you write that answer. It's one and the same thing. So I'm giving you that job to simplify it. Y equals x squared plus 1. So this is a what? This is a parabola. Let me just use the functional notation. This is the parabola, meaning that it's a many-to-one function, but its inverse, it won't be a function, it becomes a relation. So you can't use this notation. Okay. X squared plus 1, which is x 2y squared plus 1. Then we make y the subjects of the formula. Divide by 2, then these they cancel. We'll have y squared equals x over 2 minus half. We are not looking for y squared but for y. You do the math, then the answer that you will get here, it becomes the inverse. I don't know if you guys are understanding it. So it's very, very important for you to know this. It's very important. So this thing of an inverse, it works like this. The inverse of your dad is your mom. You see. So where is your mom? For example, let me say there are people who are coming to your house to visit you guys. Then they want to talk to your father. Then your father is not there. The only person that is present is your mom. They will talk to her. Why? Because she is the inverse of your dad. But if they find you, they won't talk to you. I don't know if you understand it. All right. We'll continue with the inverse graphs because they can give you an equation like this or a function like this. Then they want you to draw this function with its inverse in the same set of axes. All right. So an inverse actually it is a reflection about the origin, or it is the reflection about the line y equals x. So that line y equals x, it is the line that goes through the origin. So this is the line y equals x. It comes out from the linear function. So in other words, they did what? They substituted 0 where there's c, then the gradient it becomes 1. Then you simplify this, you'll have y equals x. So that's the line. It comes out from the linear graph. So it's very important when they ask you, sometimes in the exam they will say, draw the original graph with its inverse and the line y equals x in the same set of axes. So it's very important for you to show them this line. Okay, let us do the first example. Let me say you are given, let me just use the very same graph. They want you to draw this graph and its inverse, as well as the line y equals x. Okay, this is what I always tell my learners to do. Just use the table method, it becomes more easier. Because if I was just telling you that do this and do that without doing this table method, you wouldn't understand it. But let's hope that you're going to understand this one. So this is the table for the original graph. Then this becomes a table for the inverse. Since you can see here we have x and here we have y, for us to write the inverse table of this graph, we have to solve x and y. So I always tell my learners to put -1, 0, or 1, even if they put -2, but from a negative number to a positive number. Or even if you can use y-intercepts and x-intercepts, still it's one and the same thing. -1, 0, 1. Then these are x values. Therefore, since where there's x, you put -1. Therefore, -1 plus 1, it will be 0. 0 plus 1, it will be 1. 1 plus 1, it will be 2. Even here it's 0, 1, and 2. Therefore, I have to draw that original graph with its inverse and the line y equals x. Alright, now let's check in. Let me say we have -2, we have -2, +2, and -2. Okay, let me draw the original graph first. X -1 is to 0, it's here. 0 is to +1, it's somewhere here. 1 is +2, 1 is here, and +2, it's there. And you just draw your graph. So this is the original graph of f. Right? Let me draw what the inverse. These are the inverse points. Let me just use a different color. Okay, -1 is to 0. -1 is somewhere here. Then 0 is to 1. -1 is to 0. Okay. Then 0 is to 1. It's here. Then 1 is to 2. 1 is to 2. Then just use your ruler. Then you draw. You're joining those points. So this is the inverse. This is actually fighting with me. This is the inverse graph, right? Then what about the line y equals x? The line y equals x, you draw it passing through the center. So it's y equals x. Now I'm done sketching my three graphs, the original graph, the inverse, and the line y equals x. I don't know if you understand that. So it's very important. Let me just do the second example to check if we are still following. Okay. Let me say we have a parabola like this. An example, we have f of x equals x squared. Now a parabola is a many to one and its inverse, it is not a function. Therefore we must draw, let me just make this table to be a little bit long. X, y, negative 1, 0, and 1. Y, x, negative 1, 0, and 1. Therefore, where there's negative 1, I substitute it on the original equation. So I will have positive 1, I will have 0, I will have 1. Near 1, 0, 1. Okay, you just take these x values and substitute it there. Punch them on your calculators. Okay, it will be 1, 1, 1, 1. Okay, so this graph will be negative 1 is here, and positive 1 is there. 0 on the origin, and positive 1 is to 1 there. Then I draw my graph, or I join my points. This is the original graph. Therefore, let us draw the inverse. So the inverse, in your mind, you think the inverse will look down, or it will be a side graph. No, it won't be like that. Just use this method. If you are not using it, you will think it is having a as negative or having a set phase. So negative 1 is to positive 1. It's here. Therefore 0 is to 0. It's there. 1 is to 1. This point is somewhere here. Then you just join those points. So this becomes the inverse, but remember we can't use this one. You are wrong if you use that one. Why? Because the inverse of a many to one function, it's not a function. Why am I saying it's not a function? When I draw a vertical line test, the vertical line test touches the graph 2 times, meaning that it is not a function, it is called a relation. I've explained that on the first part. So make sure that you go back and do it and watch those videos. So it's very, very important, guys. So we will end here. We won't draw the inverse of the exponential. Why? Because the inverse of an exponential will it will want us to do what? To use the concept known as logarithms or logs. So we'll do them separate. Okay, let's talk about the domain and range. Domain and range. So a domain, it's x, the element of all real numbers. Remember, for all parabolas, this is a domain. Then what about the range? From this equation, ax plus p squared plus q. What you are looking for, you check the sign of a, then you take q. So if a is positive, you will say, we are still talking about the range, right? If a is positive, you say y greater than or equal to, then you take the value of q with its sign. But if a is negative, you will say, or you will write y less than or equal to negative q. If or positive or negative q depending on the symbol of q. I don't know if you understand that. But since now we are having a here as positive, meaning that our range will be y greater than or equal to, then what's the value of q? It's 0. I don't know if you understand that. If we're something like this, y equals x squared minus 1, the range it will be y, we can see that the a is positive, greater than or equal to negative 1. But if the a was negative, it will be y less than or equal to negative 1. I don't know if you understand that. So this is the domain for the original graph. And this is the range of the original graph. Therefore, let us write the inverses or the domain of the inverse and the range of an inverse. So it's very, very important, guys, for you to know that, remember, for us to write inverse points, we have to swap every x and y values or y coordinates with each other. It's not like here we are going to put y and here we're going to put x. No, we'll put x here. Even here, we will put y. But what is it that we're going to write here? Here we write the answer of a range of the original graph. I don't know if you understand that. So we're going to take this one and put it here. Then we're going to take this one or that answer and put it here. It's not like domain becomes range and range becomes domain. No, it doesn't work like that. It doesn't work like that. So I don't know if you understood this. Let me just do another one. Maybe you can, let me say you have y equals negative x squared plus 9. Then the domain of the original graph, it will be x is the element of all real numbers. Then its range, it will be y. Then we check the value of a. Since it's negative, it will be less than or equal to. Then you take the q or 9 with its sign. Then they want us to write the inverse. The inverse. It's still x, then the range. It's also still y. But now we won't take this and write it here, but we will just swap it to go to the domain part. It will be x less than 9, and we take this one and we write it there. It will be x is the element of all real numbers. I don't know if you understand this, guys. It's very, very important. It's very important. So make sure that you know this. We are continuing. You are allowed to pause the video and you're allowed to pause the video to make sure that you understood what I was doing. So there's something known as restricting domain. Restricting domain. We talk only about the domain. So why are we restricting the domain? We are restricting the domain so that the inverse of the graph becomes a function. I don't know if you understand that. The inverse of the original graph becomes a function. Meaning that since the inverse here is not a function, we can do something to make it to be a function. I don't know if you understand that. So there are two restrictions which you have to know. So these are the restrictions which we are going to use or we can use to make the inverse of a graph to become a function. We know that this is a function, it's a many-to-one function, but this one is a relation. So since it is a relation, for us to make it to be a function, we have to restrict the domain of the original graph in order for us to do what? To make the inverse becomes a function. I don't know if you understand that. So how are we going to do it? Let me say we choose this first restriction. We cancel that other one. It's not like maybe if I use that one, I will be wrong. No, I will be still very correct. But now we'll do both of them to restrict the domain of the original graph graph so we can make its inverse become a function. Now, what does this mean? When we restrict the domain of the original graph, actually we are cutting the original graph and its inverse in the turning point or at the turning point. Now, how are we going to use this? We want to cut the graph where x is greater than 0. So when we talk about something that is greater than 0, that thing is positive. So we want the graph where the x values are positive or are equals to 0. So x it is equal to 0 here in the origin or at the origin. I don't know if you understand that. Now, x greater than 0. So this is the part we want to see in our or on our graph. So we don't want to see the part where x is what is negative. Remember, we are restricting the domain of the original graph. Therefore, if you can check here, the x values are what? Are negative. Therefore, I have to cancel this arm or cut the turning point. You see that? And I will cancel this part here. Since I've cancelled those lines, you can see that the x values are positive. The x values are positive. The x values of a original graph, they are positive. Okay, let me just erase here and show you something. The x values of the original graph are positive, and x, it is what? It is also 0. Why? Because x in the y-axis, it is also 0, or it is the line y equals, it is the line x equals 0, because every x value here in our y-axis is always 0. I don't know if you understand that. It's very, very important, guys. It's very important. Now let me say we use this one. Let me just draw that graph again. Let me just draw that graph. Okay, before I can continue the graph, let me just explain something. Now, the inverse became now a function. Why? Because when I draw a vertical line test here, it will touch the graph once. Now the inverse became what? A function. So this is how I restricted the domain. So in an exam, they can say that you must write the restriction so that the original graph, so that the inverse becomes a function. Then they want you to draw it. Just draw all of it, then after that you use whatever restriction, or if they stated which restriction to use, you can just use. But if they didn't state, you just choose any from those. Okay, let me do that other restriction. Or let me just use the other restriction to make the inverse become a function. Okay, now we want to use this one now. We want where the graph or the x values, the x values are less than 0 or are negative or equal to 0. Now, here the positive x values of the original graph, the x values of the original graph are what? Are positive on this side. So we don't want to see it. We want to see it where x is negative on that other side. Meaning that we have to do what? We have to remove this part. We have to remove that part. We don't want to see it. So this is the original graph of the restriction x less than or equal to 0. Okay, let's check. X is negative on this side. X is negative. And x is less than 0 or equals to 0. It is equal to 0 here and here on the y-axis. I don't know if you understand that. Now, its inverse, remember this is the inverse, right? It became what? A function. So it's very important that you guys understand this. It's very, very important. It's very important. So we only restrict the domain of the original graph to make its inverse becomes a function. Okay. Let me just give you this one, then you restrict it. Remember, the only or okay, let me Okay, what you must do here, remember this is the original graph, then this becomes the inverse. So make the inverse of this graph to become a function. Use this restriction. But in an exam, they might be specific, or they must just ask you to do what? To restrict the domain. To restrict, yes, the domain of the original graph to make its inverse becomes a function. You can use this one, or you can use that other one. It's up to you. But this is my work I'm giving you because I'm in charge here. So use this one, or use this restriction to restrict the domain so that its inverse becomes a function. Thank you guys. This is the end part of our lesson today. So please do not forget to subscribe, like, share, and comment. And the next part we will be doing logarithms or log functions. So it's very important. That is why, remember here we didn't talk about the inverse of an exponential because it will need us to know the concept of logarithm. So we're going to do it side after this video is the one that is following. So please guys, do not forget to tell your friends, your relatives to subscribe, like, share, and comment. So in your commenting, even if you can say, we thank you, Maths and Science series, we appreciate that. Thank you guys.